All right, guys, so here's my next project. It is a golf cart that I got for free from my neighbor because the lead acid batteries in it are completely fried. So he offered it to me. I said yes. I rolled it into my shop, not knowing exactly what I was going to do with it. But then about 2 days later, I get an email from this company, Vatrer, who makes, amongst other things, conversions for old golf carts to convert them from the lead acid batteries to a modern lithium battery. Now, they make them in 36 volt. They also make them in 48 volt. They also make battery packs for RVs, for boats, for your whole house storage system, that kind of thing. But what we're focusing on is the golf cart conversion, and they offered me this conversion for free as well. So we have exactly $0 into this beast, and we should be able to wind up with a perfectly functioning golf cart that, according to their paperwork, can go almost 50 miles on a charge. All we have to do is get this thing converted over. So let me go ahead and take these covers off to show you what we're working with. All right, so now we've got a good look at our drivetrain here. It's pretty simple. We have our drive motor in the back, and then we have six 6-volt batteries in the front here. The issue that made this thing stop running, somewhere there was an electrical short, and it caused an overheating issue. You can see this cable is all just totally crispy, and you can see the cable on the inside. This battery is melted on the side. It almost poked a hole right through there. Would have had all that acid pour out. This top terminal clearly overheated. You can see that battery cable is all messed up, and it's kind of melting its way in. So very unsafe condition here. What I have to do, get this all cleaned up. I'll get all of these battery cables removed. We'll get these old batteries set off to the side, and then we have to fix the electrical problem before we go hooking up our fancy battery to it. So I'll go ahead and get this thing running on 3 12-volt batteries that I've got lying around, just some old lead acid ones, just to make sure that everything's working. Once we get everything working, we'll then remove those lead acid batteries, and we can hook up our fancy Vatrer battery pack. So let's get this thing cleaned up. Because these battery cables are all the same color, I went ahead and used some masking tape to label out which ones went where before I removed the batteries. Well, this thing ended up cleaning up rather nicely. The only cable I see that has a ton of damage that's still on here is this one right here. And this could have been the problem all along. It could have gotten too close to one of these bolts and shorted out, or it could have just gotten too close to this resistor and ended up getting a little bit too hot. But I should be able to just replace this one cable and then hook this up to the 36 volt negative, hook this up to the 36 volt positive on our lead acid batteries, and then we'll see if this thing runs. So let's do that. All right, so I've got 3 lead acid batteries set up here with jumper cables connecting it. We've got positive, negative, positive, negative, positive, negative going down the row. So we've got 36 volts coming out of here. I hooked up through this jumper cable to the existing 36 volt inputs. Boy, it did not like that. It started arcing immediately. And not like a little arc, like a big trying to destroy my battery arc, which is probably why we've got 6 destroyed batteries over there. So even with this new cable, there's still something going on here. I don't know exactly what it is yet. I'll have to track down a wiring schematic for this and then go through component by component to try and find where the problem is. I'm not super in love with this control setup we've got here with these giant heating coils as resistors. And then we've got a super crude potentiometer down there. I'm certain that they make some type of a new upgrade, so I may look into that. Since I have no money into the golf cart and no money into the battery, it wouldn't be the end of the world if I have to end up buying a better control unit. It'd probably be a lot more efficient, especially without all those heating coils on it. But before we get to that, let me take a look at a wiring schematic and see what I can figure out about why we're still having issues with this current setup. All right, we're learning a little bit more about what our potential problem is. I did end up having a short somewhere between the aperture and the windings on this motor, so I went ahead and disconnected all of the battery cables so that I could bench test it. I've got it hooked up with some jumper cables here just to a 12 volt. Let me show you what I found out. So the motor itself is working just fine. I just have to figure out where that short is coming from, and so it's got to be somewhere in our controller over here. So let me just keep digging in and see what we find. All right, so I found this wiring schematic online. It is not for this exact model, but it is relatively close. And after looking at this, I was realizing that cable that was totally melted was nowhere on the schematic. So I disconnected that cable, and then wouldn't you know it, everything tested fine. Well, except for the solenoid. The solenoid is currently stuck open, but that shouldn't really have any effect on it. So what I did, I hooked up that same cable that I just had over here to our positive side, and then I roughly hooked up our negative right here with just this little clamp. That way I didn't have to solder on a lug. And let me show you what I found out. Well, wouldn't you know, it works just fine. So the tires are moving backwards here, and we'll go ahead and flip that this way, and then look at that. tires are moving forward. All right, so we've got everything working, albeit on 12 volts, but we are not quite out of the woods yet because we still have to figure out what to do with this solenoid. The fact that it's stuck in the on position is actually a good thing for testing because it bypasses all of our safety switches, but we are going to want those safety switches once we put in our better battery pack. So I have to figure out now how I'm going to be wiring this because the current setup is all on 6 volts. We had a single positive right here that goes to our ignition switch that then runs to a safety switch to make sure you are all the way in forward or all the way in reverse. It then goes down to a third switch which makes sure that the pedal is actually depressed before it sends voltage to our solenoid, which then opens up the connections for everything else. What I have to do is figure out if I can find a 36 volt solenoid and then make sure that the switch for the pedal and then for the reverse are capable of handling 36 volts. And then either the same thing with the ignition switch here, make sure that that can handle 36 volts or get a new one or eliminate it entirely because I will have a on-off switch on my battery pack. And then once we get that wiring figured out, I'd like to remove this control board along with our forward reverse switch and then send those through my ultrasonic cleaner. Basically just make sure all of our electrical connections from front to back are in good clean shape before we go ahead and hook up our Vatrer battery pack. I went ahead and replaced the bolts on the resistors because the middle two had a decent amount of corrosion on them. All right, I've got the Vatrer battery mounted up. This is just going to be temporary. It's not going to live back here, but as you can see, it is a large rectangle, and I don't have space for it right here. We have space for 6 batteries, but they have to be kind of placed around our little control unit here. So I've got this temporarily set up in the back. It is all fully charged. You can see on our display, we are at 98%. Let me walk you through the wiring. It's just a little bit different than it was when it was stock. We have our positive wire coming over here to a 100 amp breaker. I put that there just in case. You know, this thing is a little bit janky, especially with these large resistors on there, and so I thought that was some good protection for it. I did go ahead and clean everything on our forward to reverse switch there. We've got a new solenoid. Let me go to the other side and show you how that's wired up. All right, so we've got a negative lead coming right here down to our switch that activates as soon as the pedal is depressed forward, and then that completes the circuit on the ground side of our solenoid. And then for the positive side, I stole from right here our main power in over to this switch here that just makes sure that you are fully in forward or reverse before sending the positive power to the solenoid. So essentially, as soon as you push down on the pedal, as long as you are fully in forward or fully in reverse, then it should activate the solenoid and we should get power to the motor. So let's go ahead and get this battery turned on right here. There we go. We're getting a green light, and then we'll go ahead and turn on our display. All right, looking good, 98%. Let's see how everything works. So we're all the way forward. Let's go ahead and hit the pedal. Here we go. Ooh, you can see the current. That's cool. Let's see what that current draw is. It says it can do 4 hours at this speed before it's empty. That's crazy. I don't know really how to read the current. It's showing negative 19 amps. Interesting. But everything is looking good, so let's go ahead and get this all cleaned up. Then we can take this thing for a test drive. All right, ready?
Yep.
All right, forward. Hold on to these. And let's go. Hey. Should we go check on the chickens?
Sure.
Hey ladies, you like our new wheels? Alright, let's head up to the mailbox. Let's see if we can do a little burnout. You know what a burnout is?
No.
We spin your tires real fast. Should we try?
Yeah.
Yeah, like that. Yeah, because the tires are spinning. Should I slide? Should I skid in there? Ready? Here it comes. 3, 2, 1. That was fun, right? Yeah. See you later. Thanks for going with me. All right, guys, so we just went on our first little test drive. Everything went well, but check this out. I've got my thermal camera here to show you guys just how incredibly hot those resistors get while driving this thing around, even for a short distance. So the fact that we're wasting all that energy in heat and we're making that much heat in an area where I'm going to be driving around with, you know, dried grass and whatnot makes this not the ideal solution long term. Like I said before, I do plan on swapping all this out, not just for that heat and the wasted energy, the fact that the battery can't fit in here with this contraption. So eventually I do plan on swapping this out to a controller. If you guys have done that in the past and you've got any good references for me, go ahead and put that information in the description. Now, I did want to go over some of the differences between a lithium battery pack like the Vatrer that we've got here and our original lead acid batteries, specifically things like the energy density and the weight, the voltage that they operate, that kind of thing. However, when I started to do the research, I found out that a good friend of mine in Arizona had already done a very similar conversion where he installed a Vatrer battery pack into an RV, and he did a way better job of describing the conversion than I ever could. So I'm going to add a link in the description below so you can head over there and check that out if you're interested in like the really nerdy aspect of a conversion like this. Otherwise, that's it. Thanks for making it this far. See you guys later.